So once we discuss about the obstacle avoidance robot earlier, then we had a very clear-cut discussion that we will have a robot like this. Assume this is the robot. Like once you have a single sensor, and this is your sensor named as S, and this sensor can transmit and can receive. So this is the transmit and receive the IR signals, and the width of sensing will be limited with the size of the sensor. Wherever the size of your robot is much bigger, so this is the size, extended size, this is also extended size of your robot. So this robot size is much bigger than the size of the sensor. So once there is an obstacle like this, the obstacle can be like this, an obstacle can be, and if this is an obstacle, then your sensor will detect as no obstacle. However, this body can meet to an accident, and there is a collision because the size of the body is more than the size of your sensor. So this is your obstacle, and the size of your body is more, but the sensor is detecting as no obstacle because the distance is more to the obstacle from where the sensor is actually approaching to the object or obstacle. So right now you need to think of it how to avoid this case. So what we can do, pretty simple change in the structure. We can just do one thing, we can put one sensor here, one sensor here. So this sensor will take care of this side, this sensor will take care. So there is no more middle sensor right now. So you can have two sensors in the two side. So right now these two sensors can save your robot by avoiding this obstacle. So right now there is a two sensors required. Assume in this case the obstacle shape will be changing like this. So if the obstacle shape is like this, then right now the obstacle shape is like this, and the obstacle, both the sensor is not detecting as an obstacle. However, the obstacle is pretty near to your robot. Then what is the scenario? So the scenario is right now changes a different case. Right now the obstacle is looks like an edge, and the edge of the obstacle is between your two sensor and which is going to hit your robot. But meantime you are moving forward. Because your robot doesn't detect any obstacle. So in this case you need to have three sensors at least. So the third sensor can be here, and which can detect there is an obstacle and can say yes obstacle, so that your robot can go. So let's go with an example how to build a robot with a single sensor. Then we'll go to the second sensor, then we'll go to the third sensor, and we'll develop the algorithm and project and go ahead. Right. So right now we have a robot, this is a robot assume, and we have a single sensor. So the sensor can detect either yes obstacle or no obstacle. If yes obstacle, what you need to do? So right now I can say write the status of the robot. It can be yes obstacle, it can be no obstacle. Then the action against to the status, the action could be here. Action will be yes obstacle, then you can be, you can take an action, stop the robot, or no obstacle, you can write move forward. So I am writing forward as FWD, so it says move forward. So if you can create a table out of it, like this, looks like this. It's a small table where you can see the action, the status is yes obstacle, and action is stop. The status is no obstacle, the action is move forward. So right now let's develop an algorithm based on this. So you can write step 1 will be start the robot, then it will be step 2 read input, then the step 3, check for obstacle. Check for obstacle. It will be again, there will be things once you check for obstacle, there will be like if yes, go to step 4, else go to step 5. So let's go to the step 4. What does it do in step 4? If yes obstacle, then you need to come to the step 4. If you come to the step 4, pretty simple. You need to say stop the robot and go to step 2. That's what your robot can stop and go to the step 2 like this. If it is the case, yes. Else, what is the answer? Go to the step 5. So right now go to the step 5. Step 5. Then you find what? If there is no obstacle, move forward your robot and again go to step 2. This itself gives an example of never ending loop, the basic embedded system. So here the loop doesn't end, but as a formal end or closure of the program or algorithm, we can write step 6 as END, or you can give a stop. This is the basic algorithm. Start the robot, second step read input, third step check for obstacles. Fourth, again here once you check for obstacle, there are two options, either yes obstacle or no obstacle. If yes obstacle, then go to step 4. If no obstacle, then go to step 5. Once you come to step 4, stop the robot, go to step 2. Once move forward, then go to step 2. Once you go to step 5, no obstacle, then come to the step 4, 5, then move forward your robot and go to step 2. Then step 6 is end. Then the flow chart. The flow chart, let's see the flow chart. Start. Read input, then you have conditions block. Either you have a obstacle question mark. So the answer can be go like this. Either it can be yes obstacle or it will be no. If yes obstacle, then you need to stop your robot. If no obstacle, then you need to write move forward. Then both the things, after moving stop, you also need to go to the read input. After move forward, you also go to the read input. And once your robot and the basic closure of the flowchart is your end. So we start the project here. Start, check for the read input, then check for obstacle step 3. If yes obstacle, stop the robot and go to read input. If no obstacle, move forward and go to the read input. So it will be a never ending, either obstacle is there or no, you need to go read input and come to the end.